Hello. Welcome back to the continuing lecture series in investment analysis. This is Dr. Jeff Hong, and this is the third video in the same topic, the topic of uh, bond price and bond yields. Now, so as pre-announced in the previous video segment, we're gonna do this example of bond pricing and bond yield. Now, first of all, this file, you will find this file in the topics folder, right? The Excel file labeled bond exercise 0. Now, the narratives, or the scenario is, some people might wonder, where's the word? I don't like words, right? We don't, first of all, it's not that I hate words, but, too much verbiage, I don't like too much verbiage. In this day and age, there's such a plethora of verbal information. We are actually, inundated. We are inundated, literally, in the verbal messages, verbal narratives, verbiages, right? In short. But then you might wonder, how do I know what to do without the verbal instruction? That's relying on the verbal instruction is, of course, if you're completely out of context, it's impossible without any instruction. But if you're in a context, the scenarios are pretty much straightforward, and it's obvious from the scenario. For example, if you are a professional, seasoned professional, in whatever occupation you're doing, you know the story. The scenario is quite obvious. It always goes. There's a certain routine or the standard operating procedure. You know what happened, in the previous sequence, and so what should happen in the current sequence, and what will happen in the next sequence. So we are put into a bond context. So the scenario is quite obvious, and people who just always keep whining about words. That's elementary school, right? And this day and age, you can't read. I sometimes I have to write a very long. I have to write a very long report or a very long paper, long article. It's inevitable because the logic and the thought process takes multiple steps, and you have to pull through all of those stages of reasoning. But usually when everything is too long, when everything is already quite obvious from the context, then we can just bypass the unnecessary, lengthy, wordy verbiage. Okay. Now, so in that sense, we can tell what is the scenario here. That's future value, of course, or face value in the bond context, right? Because always in the face value or the par value is the maturity value as well as the face value of the bond, and it's always $1,000. And what is this? This is the coupon rate. Of course, I normally use IC, right? I normally use IC for coupon rate, but in this case, I simply so let me. Okay, let me unify all of the. Okay, and so coupon rate. So this bond pays 7% coupon rate. So it's a wonderful, may not be wonderful these days, but I mean, not normally, but these days it's a wonderful, wonderful coupon rate, because where can you earn 7%? Fixed income of 7% these days. You put your money in the bank, in the CDs, you can barely earn 1% these days. Now, M stands for compounding frequency per year, right? And once again, if you have taken Finance 100 with me, I keep using the same symbol. So this was also the symbol for compounding frequency per year in Finance 100. This is the payment or coupon payment. And then $35. Now you might wonder, okay, coupon rate is 7%, and it's 1,000. So shouldn't it be $70? Yes, it's $70 a year, but since coupons are semi-annual, what does that? What does that mean? Half a semi-annually should be $35, and I didn't enter it manually. It is the old soft coding, it's simply the formula, right? I found it by the formula. By definition, this type of formula is simply the definition of what the coupon payment is, right? That's what coupon payment is, right? The only thing that goes in as numerical data are the input data, like this. Think about it. You have it. It's the initial condition. Coupon rate must be given as initial condition, right? Compounding frequency must be given as initial condition, but these two are relatively already given, because there's no bond that has other face value than $1,000, right? If you remember, the only exception is the municipal bond. Only municipal bond has different face value of $5,000, but otherwise all bonds have face value of 1,000. So, and then all bonds, if they are coupon bonds, right? And there are coupon bonds and zero coupon bonds, and zero coupon bonds don't pay any interest. But if they are paying interest, it's always semi-annual. So compounding frequency is 2 always. Now, 20 years, this must be given. So it's an initial input data or initial condition. And N stands for actual number of compounding, or total number of compounding. Or in this case, there are 2 compoundings per year, so there will be 40 compoundings, right? 40 compoundings over 40 years, and also over 20 years. And that also can be easily, right, found by its own definition. It's not even math. This is not formula. It's just definition, right? All definitions can be mathematically defined, right? Now think about it. Something like if you a statement like, if you don't exercise, let's make it simple. In 20 years, you'll grow 20 years older, right? This statement. Can we turn it into, can we express it mathematically? Yes, of course. Let's say your age now, let's call it A0, right? And then whatever your age is, you can call it X0, right? Or X0. And let's give time T, T equals 20, right? Then 20 years later, your age will be expressed as X subscript 20, right? Or we can call it X1. And so X1 is defined as then X0 plus 20. Isn't that right? And because being, X being, number of years, it can be added, numbers can be added to X0 or subtracted from X1. So then X1 is defined as, right, it's all words, so let me use my, favorite tool. It's not really my favorite tool because it's really hard to use. So the X1 is defined as X0 plus T. Okay? And then X1 is greater than X0, right? Of course, you want to declare if let X0 current age. It's really difficult to current age, right? Because it's not really writing, it's actually drawing with the mouse. And let T 20 years. And then X1 can be defined as, right, X0. So you get the idea. I don't want to stay, too long with this, but this is how you define that 20 years later you'll be older than now. I mean, that's obvious, but I don't want to use words. Instead of saying it in verbally like that, how concise and how terse this is, and how logical this is, right? If everything can be expressed this way, we can cut down on time. We don't have to be reading everything, But anyway, let's not. Let me. Erase all that. Anyway, so and then APR. This is the prevailing rate, or the discount rate. This is the prevailing market rate. So this is the yield, right? This is the yield to maturity. Of course, this is coupon payment, right? So the prevailing rate, market rate is interest rate is 6%. Then, or what is this? This is the half-year rate. This is the half-year rate. It has to be. Why? Because we are dealing with half-year, semi-annual compounding, right? So we need discount rate for semi-annual discount rate, which is simply, we already know how we got to this. You divide APR yield by 2, and then this is a present value of that bond that pays $35 every 6 months, and will eventually end up paying $1,000 20 years later. We know the formula. First, it's the present value of annuities. So it's the payment over R minus payment over R times 1 plus R raised to N, right? Close parenthesis. And this is only the present value of the annuities. Now, present value of this, par value, single sum, we divide it also by 1 plus R raised to N. Okay, and then hit enter. Okay, we got that. And this is B, right? The intrinsic value of the bond. And think about it. We could tell this is a premium bond or discount bond. Oh, it's a premium bond because the price is greater than the par value, or the maturity value, right? Maturity value or par value. Oops. Okay. But you could tell, you could be, even before you calculated this, you could tell that it would be a premium bond. Why? Look at the coupon rate. The coupon rate is greater than, the prevailing market rate. So you could already tell that this would be the, a premium bond. That's just, okay, one example. Now, there are examples, sometimes, okay, so let me, as I said, bond prices are expressed as percentage of the par value, So, normally you would express it as 100, right? This is 100% of $1,000. This is not $100. It's $1,000. But I for convenience I continue to use dollar sign. But you understand it's 100% of 1,000. 5.5% coupon rate. And then, of course, it's always semi-annual, right? So the coupon payment it's not $2.75, it's 27.50, right? And of course, by the same, I didn't have to do this over again. I just copied this and pasted it here. And then the maturity, time to maturity is 15 years. So actual number of coupon payments or actual number of compounding would be 30. And the here it's R, but I used okay. Let me. I can even copy that. R is usually the notation for half-year rate, but here it is the full year APR, the same thing as APR, because it's. But why did I call it R here? Because I wanted to use the term internal rate of return here. Internal rate of return, IR. Now, I will need to explain this later. But internal rate of return is if you took a Finance 100 with me, it was already explained. That's what makes the left-hand side of the equation equal to the right-hand side of the equation. In other words, you're solving for the present value. So the left-hand side of the equation is left-hand side of the equal sign is the present value, and on the right-hand side, it's all future cash flows, and you must discount it to present. So depending on what the discount rate is, the right-hand side can be equal to left-hand side or not equal to the left-hand side. So that means there is only one discount rate that will make the right-hand side equal to the left-hand side. That's mathematical definition of internal rate of return. But anyway, to do this, to use this setup, right? Once again, in this setup, you see all prices are expressed as percentage of. What is this? What is that? All prices are expressed as percentage of par value of $1,000, right? Now, so we want to find, intrinsic value of the bond, while prices are all expressed as percentage of the par value, and when the time is given, as calendar date. So T0, T sub 0, that's today's, time 0 is always now, right? And uppercase T is the terminal time, so that is the maturity. So this bond today is November 15th, 2011. Let's say this bond matures in 2026 on November 11th. Actually, this is usually the maturity would be like either February or August. But let's say if this is the case, then this 15 years was not just random. Oh, it was given. Okay, that's why with 15 years given, if today is November 15th, 2011, 15 years later will be that date. And I found that, maturity date this way. Of course, this is, J19, which is, today's date, calendar date. And then 15 years, which is E19 is 15 years. And then I had to multiply it by 365 because that's the number of days. And you might wonder, can you not just add, 15 to, no, you can't. It will recognize, if you have calendar date here, it will recognize it as days, number of days, right? So you had to, it's 15 years, not 15 days, so I had to multiply it by 365. So again, so then how do you find the, we're going to use price function. We can do it this way, but time zero and maturity are given, right? We're going to use price function. The price function, Excel has built-in price function, right? Just enter, a couple of, and it's going to price. First, it's asking for settlement. That means what? Settlement date. Settlement means, the transaction is settled. In other words, you bought and the other guy sold, right? So today is the settlement date, because otherwise, why would today matter? I mean, because you're buying, even if you don't actually buy the bond today, but you can assume you're buying it today, right? So today is always the settlement date, okay? And then maturity is there. So you click it in. I'm not typing it in. Some people, if you've taken Finance 100 with me, I'm clicking in with the mouse, right? You don't type it in. That's very like a slog, if you type it in. Also, if you've taken Business 210 with me, you would know that. And then comma, you have to see, it's a syntax. If you don't put comma, it causes error. And then rate means what? Rate means the coupon rate. So rate always means coupon rate in this command. And then yield is here. Okay, 6. And then what else? Redemption value, which is another name for maturity value or par value, redemption value. And then frequency, it's semi-annual. You can enter these days, this function has either 1, 2, 4. You can click on this, or you can enter this, right? Okay. Now, since the parenthesis is opened, you must close it. You don't have to close it manually. You can just enter this formula, and Excel will automatically close it. Okay. There you go. Close. And it gave you this. Again, don't tell me, you might say, oh, so that's 90,050. No. It's percentage of the par value. It's 90.51% of $1,000. In other words, $905.10. Okay? Makes sense? Now, suppose you had the same problem. So let's try this. I'll make it equal to this. Okay, and I'll make this equal to I'll make time equal to this. I'll make all the input data equal to, right, second problem. Then okay, what do you get? You get 905.09. Okay, 905.09, right? So that's what it is. I mean, 09 is almost 10 cents, right? 9 cents, rounded to 10 cents. And then what else? Before we even calculated it, we could tell it would be this is a discount bond, isn't it right? And you could tell already it's going to be a discount bond. Why? Because look at the, right? Look at the coupon rate. And coupon rate is less than the yield, right? Or the discount rate. And of course, then it would have to be a discount bond. All righty. So our next example, we're going to skip this and go straight. This is an exercise to find yield. We're going to come back to this, but after doing this spreadsheet 10.1, okay, so it will take another 30 minutes to do this, to the next. So let me stop the recording. Let me stop the recording at this point here, and then I'll see you back in the next video with the next example. Okay? Stop recording.